everybody. Thank you for joining this webinar today on Spring Apache Hadoop and Pivotal HD. My name is Adam Shook, and I'm a technical architect for Pivotal. I have about 2+ years of Hadoop experience working with the Hadoop Core, HBase, Accumulo, Pig, as well as Zookeeper and other related technologies. I've also been an instructor for Hadoop-based courses for a little while now. Mark Pollack will be joining us later and talking more about Spring Hadoop. He's been a Spring committer since 2003, founder of Spring.net, and is the lead on the Spring Data family of projects. So just a little bit about the agenda of what we're going to be going over. First we're going to talk about what is Hadoop, at kind of a high-level overview of it. A little bit about Pivotal HD and what it is that we have inside the Pivotal stack. We'll be focusing a little on HAWQ as well, kind of our SQL services for Hadoop. And Mark's going to be talking to us too about Spring for Apache Hadoop. And then at the end, we'll have some time for some questions. So with that said, let's kind of dive in here and talk about, what is Hadoop and why is Hadoop important these days. And Hadoop, delivers performance and scalability at a low cost, handles huge amounts of data. We're talking, multi-petabyte scale. As well as storing this data in a native format. So whatever you have, whether it's unstructured, structured data, images, videos, anything like that, it'll store it inside the file system. Now it's very resilient in case of infrastructure failures. Failures at expectation of this when you're dealing with massive clusters. Disks are going to drive, nodes are going to go down. It also supports transparent application scalability. So whatever application that you write, MapReduce application for Hadoop. No matter if it's on a 10-node cluster or 100-node cluster, it'll scale out transparently and not require you to actually do anything. So an overview of Hadoop. It's an open source Apache project. Came out of Yahoo in about 2006. One-liner of what is Hadoop. I say it's a distributed, fault-tolerant data storage and batch processing system. It also has linear scalability on commodity hardware. So if you need more data storage, more processing power, simply buy another rack of machines and add it to your Hadoop cluster. Hadoop itself is really great at this reliable storage of huge data sets, as well as kind of batch queries and analytics. It's kind of the freight truck of processing, over petabytes, terabytes of data. It's also really good at changing schemas. So since Hadoop stores it in its native kind of format, if your data schema changes, as it's coming in, you can quickly kind of adapt your code to that. You don't need to do any kind of difficult ETL or table changing processes or anything like that. So, of course, with all the good things, there's bad things. It's not very good at changes to files in that you cannot do it. The file system itself is an append-only file system. It also has, low latency responses as far as what people are used to in the SQL front end of where you submit your SQL query, it's going to come back pretty soon. And that ties into the analyst usability piece of it. So these are, batch queries that are going to take a long time to process, but they're going to take much, much shorter time than they have in the past. So HDFS itself, the Hadoop distributed file system, it's a hierarchical Unix-like file system for data storage. It has the concept of, folders and files, users, groups, permissions, everything like that. However, it's not actually this type of file system. What it does underneath, when you put a file into the file system, it essentially splits up this large file into actual blocks, the default 64 megabyte blocks. It'll then take these blocks and distribute them, replicate them across the data nodes inside the cluster. The two key services top level is the master name node. This is simply just a name server that kind of understands this file is made up of these blocks that can be found on the file system of these machines. And those machines themselves are actually data node services that are going to be running. And these data nodes are just there to kind of receive requests from clients, as well as kind of dictated from the name node of where to move data, where to put it, things like that. And another service for HDFS is called the secondary name node, or used to be called that. Now it's kind of a checkpoint node is a better name for it. This node is really just there to kind of create these checkpoints of the name node so that in the event that there is a failure, which is unlikely, you can restore the name node from a recent checkpoint. So it's not actually a hot backup. So kind of how HDFS works, a little kind of data flow diagram here. The client's going to contact the name node to actually write the data, say, hey, I want to write out this file. Here in this little demonstration, there's 4 blocks, so 64 megabytes, say it's a 256 megabyte file. The name node is going to respond to the client and basically say, write it out to all these nodes. At which point the client will start sequentially writing blocks to these different data nodes inside the cluster. And after that file is done closing, or those blocks are closing, the data nodes themselves will start to replicate this data and distribute them around the cluster up to 3 times. And this is all orchestrated by the name node process. Now your data is kind of distributed, replicated across the cluster, so that in the event that the node goes down, there's another replica there available to read the data from. And speaking of reads, the process is very similar. Essentially, the client's going to contact the name node to actually read this data and say, hey, where's this file? And the name node will respond and say, it's made up of these blocks. These blocks are located on these data nodes. Go get it. At which point, then the client will start reading these data from this data node. It'll pull, the first block from data node B, the second one from data node C, and so on. So, if a node falls over, these blocks are in other places as well, so they can get the data from there. So taking a look at the MapReduce side of things, this is MapReduce 1.0, kind of the older way, I suppose, of doing it, the stable release. There is the next generation of MapReduce, or YARN as it's called. It has a slightly different architecture, but all the code, as far as MapReduce jobs are concerned, will still work. You just need to recompile it against the newer libraries. But the whole idea behind MapReduce is essentially it's going to take your code, your jar file, and kind of move it to the data where it lies for processing. So in the same way that the HDFS takes data blocks, or takes a file, and distributes them into blocks, it does that same thing with your actual application. The master service is called the job tracker. It's meant to monitor jobs that you've submitted to the cluster. And it's responsible for monitoring their status, as well as kind of scheduling them out to multiple task tracker services. And these services run something called a task. The task tracker service itself is actually running on the same machine as a data node in order to get data locality. Some terminology, a job contains many tasks, and a task contains 1 or more task attempts. So when the job tracker submits a task to a task tracker, it's really just an attempt for it to complete it. If the task attempt were to fail, it'll start it up again on another node. Eventually, if the same task attempt fails 4 times, the whole job will fail. How MapReduce works: the client's going to submit a job to the job tracker. At this point, the job tracker will work with the name node to basically find out where these data blocks actually are. And then at that point, it's going to start submitting tasks out to the task trackers. So here, this file we put in HDFS before, we're going to submit 4 tasks at a time to these task trackers. So right there, we basically get a 4 times speed up. If we had, larger files with more data nodes, we would get that many more processing power out of it. And after the job completes, that output is written back to the data nodes, where all those files are going to be distributed, replicated, just like any other file in HDFS. And finally, the job tracker is going to report metrics back to the client, and basically just say, this is the number of bytes that were processed, this is the number of input-output records, things like that. The client then will have to actually connect, work with these data nodes to actually get the data out of it if it's interested. I'll talk a little bit about MapReduce now and exactly what it is. MapReduce is a data processing system with 2 key phases, aptly named, map and reduce. The first is just a simple map function that works on key value pairs as both input and output. And inside the map function itself, it's where you commonly do things like any filtering operations or any transformations of your data there. Next up is the kind of reduce phase of it, which runs a reduce function on key value groups. And these groups are generated through the shuffle and sort phase that we'll see in a little bit. The groups are, after they're shuffled around to all the reduced tasks that are going to be running, these groups, the tasks essentially sort all this, map output that it has to create these groups, and they're sorted on key. So here's just kind of like a walkthrough of a simple word count example. We'll see some code later. For the map input, we're going to have a key here. It's a number, which is pretty much useless. And the value here is going to be a line of text. And each one of these map tasks is going to iterate through this line of text and take out an individual word. It's going to output that word as the key, and then a number 1 is the value. And then from here, the framework is going to take over and essentially create these reduce input groups for the task. Now, it does this through the shuffling process. which is going to run a simple hash algorithm and take the modulo of the number of reduce tasks you have. And whatever that number ends up be, that's the reduce task that's going to get that key. So here, in the first group, we have fun, which came from maptask 0 and maptask 2. But since those hashing algorithms are both, they're going to run over that key, it's going to both end up to 0, so that's where those keys are going to go. After all that output is sorted, you're going to have essentially, a single instance of that key and all the values that were associated with it. Then the reduce task is going to get these groups and turn through them. Essentially, it just iterates through this list of values and creates the sum. And then it's going to output, that key with the overall sum. So let's take a look at some of the code here. Just the description of this example. For a word count, is we're going to count the number of times each word is used in a body of text. For the map input, we're going to get a line of text. Output, we're going to get the word and the total sum. So looking at the class here for WordMapper, it extends the mapper class as the base class for all Java MapReduce things in the Hadoop framework. It's templated here with 4 arguments. The first 2 are going to be the data types of the input key and the input value. And then the last 2 are going to be the output data types for the key and the value. So inside the map method, we get that key. It's that integer or long value that's kind of not as important. Then we're going to get a text object, which is that line of text. So after we get the line, we're going to use string tokenizer to basically create these words out of it. So while there are more tokens, we're going to set our output key here called word to that word, and then output it with the number 1 using that context object. And the reducer code looks pretty similar. In some reducer, it's going to extend this reducer class, base class for all reducer implementations. And it's also templated to a text int writable for input key value pairs, and we're going to output the same types for the output key value pairs, text and writable. And the reduce signature, you see here, it gets a key, just one of them, a text, and essentially this iterable over int writable values. And this is going to be all of our ones that we had that were associated with, say, the word Hadoop. So we're simply going to iterate through all these, just get kind of that integer value underneath there and sum them all up. Then we're going to output the key with the actual int writable, or the sum. So all of this actual code, is kind of packaged in this jar file. So when the task tracker gets it, it understands, I need to run this mapper class, I need to run this reducer class, as well as a lot of other configuration values that are in there. So the framework is actually handling all, where do I actually have to run these tasks? How do I handle shuffle and sort? All this stuff is built into the Hadoop framework. So you as a developer just really have to focus on, how do I solve my problem using MapReduce? So we're going to shift gears a little bit and kind of talk about what is available inside the Pivotal HD distribution. So Pivotal HD, it is the world's first true SQL processing for enterprise-ready Hadoop. This supports ANSI SQL on Hadoop using HDFS as the storage layer. It's based off 100% Apache Hadoop products. It's also virtualization and cloud-ready through VMware and Isilon, but we're not going to talk about that particular piece here today. The stack itself, for all the Apache products in green, on the left here we have Yarn, which is this next-gen MapReduce. So Pivotal HD is using HDFS 2.0 and next-gen MapReduce. It also has Zookeeper for configuration and other status things that we need it for. It has HDFS as that storage layer. On top of that, we offer HBase, which is a kind of a distributed key value store. It is the database as well as a Cumulo for Hadoop. We also have Pig, Hive, and Hadoop on the right over there, as well as MapReduce. Pig and Hive being higher level abstractions of essentially creating Java MapReduce code. Hadoop or Mahout is a machine learning library kind of built for MapReduce. Underneath the bottom there, we have Scoop and Flume, which are Apache products essentially getting data into HDFS. We also have Spring and Data Loader. And Data Loader is our Pivotal HD enterprise product for also getting data into HDFS. We have Hadoop virtualization extensions, or HVE. And these extensions essentially allow HDFS to be aware of any virtualization you may have in your environment. The native kind of HDFS, it understands your network topology as far as machines and racks are concerned if you've configured it to be that way. So it'll be smart enough that when it goes to kind of place its replicas, it won't put those 3 replicas on the same rack. It'll put 2 on one rack and 1 on another one. In the event that a rack goes down, then it won't actually lose all of your data. You'll still have a copy available, and you can re-replicate off of that one. The problem with that is when you start virtualizing this, and say you have multiple data nodes on the same actual physical machine in a rack, Hadoop might decide to put 2 replicas on those 2 data nodes. It doesn't know about the virtualization layer you have underneath. So these virtualization extensions allow you to kind of inject that layer in for HDFS. So it'll be smart enough to not actually put replicas on the same data nodes that are running on the same actual physical machine. And on the right there, we offer a command center, which is used to kind of deploy, configure, monitor, manage, all of your like the HDFS install, YARN, as well as HBase. And kind of the big piece here we offer, is HAWQ, and this is our advanced database services. This is SQL on Hadoop. It offers ANSI SQL compatibility as well as analytics through Madlib. It has an extension framework we'll talk a little bit about soon, as well as a query optimizer and dynamic pipelining. So HAWQ, it's SQL compliant, ANSI 92, 99, and 2003. It has a world-class query optimizer built into the system to kind of find the most effective way to go about running your SQL queries using data stored in HDFS. It has interactive query through a number of different clients, as well as ODBC and JDBC. It's horizontally scalable, much like Hadoop. If you need more processing power, if you want faster queries, you just add more segment servers, just like you add more data nodes or fast trackers. It has robust data management, common Hadoop formats, such as Avro sequence files, as well as deep analytics through that Madlib library. So with the query processing, again, interactive ANSI SQL support, that is huge. Multi-petabyte scalability here, cost-based query optimizer, programmable analytics. On database services, it uses a scatter-gather data loading model. Supports row, column storage, workload management, partitioning of tables, third-party tools, and open client interfaces, all usable through HAWQ. And the reason for this, essentially, we've done is have 10 years of kind of the NPP database research and development is now available for Hadoop. We've taken our NPP Greenplum database, essentially changed the storage layer to work with HDFS and interact with it. So all the cool stuff you got before with ODBC, JDBC client accesses, full ANSI SQL support, any third-party BI tools can integrate with this are now fully available for Hadoop. And kind of the one big thing we get out of this to actually get really effective queries is the query optimizer, which will generate a physical plan over your query to kind of how am I going to go about actually executing this SQL query. And it uses cost-based optimization to figure this out, including kind of knowing about what segment servers are too busy inside the cluster to make sure that they don't overload them. It also kind of inserts these motion nodes for inter-segment communication, and this is the dynamic pipelining. It's essentially efficiently pumping streams of data between these nodes during the execution. Every single segment server inside of the HAWQ installation is essentially connected to every other single segment server. So this is good for moving messages around as well as data itself. So intermediate results through your actual queries are never actually written to disk. They're just simply streamed around between these nodes. And through this technology, we can get really, really quick queries. Through the Xtension Framework, which is another piece inside of HAWQ, we can essentially work with common data formats through Avro, protocol buffers, and sequence files through external tables. So HAWQ can basically get data from things like HBase or Hive tables and kind of know how to run SQL queries on those. And it is an extensible framework to allow for connecting to kind of other data sources you might have there, whether it's kind of like homegrown ones or other things out of the box. As far as how HAWQ deployment actually looks, the top there, with screenshot of essentially just a client application using something ODBC, JDBC to submit a query to the master node. And this master node is responsible for, parsing that query, planning it, as well as dispatching it out to a number of segment servers. And these segment servers are running on the data nodes themselves in HDFS. There's also external sources that we can work with through, the GP Xtension Framework to kind of work, query other data outside of just those natively in HAWQ. So how HAWQ actually goes about working, it's just kind of a brief overview of this. So, any number of clients submits a SQL query to that master host. At this point, it's going to parse that query, kind of look at, make sure it's the right syntax, but mainly it's going to kind of optimize this to figure out what is the best plan for optimizing this query. And what's cool about that is you can have, you can submit the same query, but you might get a different actual execution plan every time, depending on if segment servers are too busy to actually run these processes. So after it optimizes it and figures out, the overall execution plan that it's going to run for that, it'll then kind of distribute this execution plan to the segment servers as well as with what data they're going to be running over. And each segment host runs a query executor that's going to start sequentially, going through this query and pulling the data from whatever sources it needs and running the query there on that node. And then it's going to use this dynamic pipelining to kind of shift data around that it needs to. Say for like a join, those results need to be running on the same machine. So using dynamic pipelining, we can shift data around. And then after the query is all completed, it's going to push that back to the master host, all the results, which will then get, sent back to the actual client themselves. So that's the HAWQ's brief overview with it. I'd like to turn it over now to Mark, who's going to be talking about Spring for Apache Hadoop.
Okay, thank you, Adam. What I'd like to cover today is covering some of the features and functionality that we have in the Spring for Apache Hadoop project, and also give some indications of where we're going to go in the future in terms of supporting big data applications using Spring technologies. One sort of general observation that led us down the path to creating Spring for Apache Hadoop is that Hadoop, at least in my opinion and several others that we've encountered over the years, has a poor out-of-the-box programming model. What this means is things are often harder to develop and code against than necessary. A lot of this is because of the historical accidents of sort of history, where other Hadoop ecosystem projects such as Pig or Hive were developed by completely different groups. So there really isn't a common thread that drives the interaction of the API with the developer. And also, once you get beyond doing hello world applications, I've seen that non-trivial applications are often a collection of scripts that call into command line utilities, Hadoop command line utilities. This isn't very structured or very maintainable. And so the goal of Spring for Apache Hadoop was to simplify developing Hadoop applications, and along the way allow you to incorporate other Spring ecosystem projects such as Spring Integration or Batch to make even more sophisticated big data solutions. So here's a small list of some of the features of Spring for Apache Hadoop. It was in development for around a year and went GA at the end of last year. It's also included in the Pivotal HD distribution, but does work with other distributions of Apache as well. The important feature that I want to highlight first is around its declarative configuration model. So you can use Spring to create and configure your connectivity to Hadoop and all the various job types, such as MapReduce jobs, Hive, Pig jobs, cascading jobs. And similarly leverage the features you're used to in the Spring container, such as environment support or property placeholders that allow you to easily move your Hadoop application from dev to QA to production. The other feature is really focused around developer productivity, meaning that you can create Hadoop applications that are well-formed and structured and not just a collection of Perl scripts or Shell scripts or Ruby scripts that organize a series of callouts to various command line utilities. We've also made some improvements in how you can access HDFS. In particular, if you've used the command line shell for accessing files and testing for their existence or moving them around. We've made the equivalent of that functionality in the command line available as an easy-to-use API that also supports JVM scripting languages, such as Groovy. For taking the next step above, running one small MapReduce job or Hive script, we have various runner classes. These implement the JDK callable interface, and these allow you to sequence a very small series of steps, allowing you to essentially run some HDFS commands, for example, to get data into Hadoop, run a job, then execute some HDFS command to get data out of Hadoop. And last but not least, one point to highlight are various template classes that you are probably familiar with in Spring, such as JDBC template or JMS template. These are helper classes that provide a lot of consistency and uniformity in how you access different systems in the Hadoop ecosystem, namely Pig. There's a Pig template, Hive template, HBase template. So if people are familiar with Spring, you'll pick that up quite quickly, seeing a common API model and things such as translation into Spring's data access exception hierarchy. The areas where you can use Spring for Apache Hadoop are quite wide-ranging. The three that are most predominant is around ingesting data into Hadoop. These could be events, stuff from databases or flat files. Orchestrating Hadoop jobs. Any non-trivial Hadoop application consists of running many Hadoop jobs in pipeline, in sequence. And here we can use something like Spring Batch workflow mechanism to exploit that feature to its fullest extent, or to meet that requirement to its fullest extent. And similarly, when your jobs are done, the data is residing in HDFS, and often you want to extract that data out to put it into yet another system so that it's more easily manageable to create reports and other things that end users want to see. So the Spring integration and Spring Batch projects really combine with Spring for Apache Hadoop is what makes you're able to implement these solutions to really address these use cases in a very powerful way. So starting small from the beginning, if you look at the standard Hadoop APIs to configure a job, you'll see you have to write code like shown on this slide. You set the mapper class, the reducer class, which Adam showed earlier, output keys and values, and then submit the job. What we've provided in Spring for Apache Hadoop is a XML namespace that allows you to, first of all, connect to HDFS and specify the configuration properties, in this case where the name node is living. This is inside the configuration element. You can then also declare a job, and here you can see we're using Spring's property placeholders to parameterize where the input path and output path is located, and then specify the mapper and reducer. And wherever we can, in order to simplify what you have to specify, we can sometimes determine through reflection what the output key or the output class is for the given job, so you don't have to specify that explicitly. And last but not least, there's a little job runner element here where you reference a job. And in this case, when the application context starts, this job will be run. And we'll see a little bit more examples of that later on, different features of the job runner. So once Spring is aware of a Hadoop job, it's a managed object just like anything else inside of the container. That means you can inject it into other Spring managed objects. So in this case, I have a fictional word service class where I've injected a job, and then I could perform additional runtime configuration if needed, and then submit it programmatically. There's also support for streaming jobs. This is where you're using non-Java-based mappers and reducers. In this case, it's sufficient to use cat and WC to implement the word count example. But what I really want to stress on this slide is less the fact that we're doing a Hadoop streaming job, but more that you can leverage Spring's environment configuration features that allow you to specify the value of the $env variable that comes from the environment that you specify when launching the application. So you see at the bottom here is a little command line that you would do to launch that. And this means if it's the dev environment, the ev environment variable is set to dev, then it'll pick up the dev properties file. Similarly, if you're running and you set that environment variable to QA, it will pick up the QA environment variable, which is a different set of properties. The features we have around the HDFS and the traditional command line shells is to expose them as a API in a class called FS shell. So this means inside your code you have very, very familiar, simple API that you're probably used to already in terms of the command line, but now you have it available inside of Java to test for the existence of files and remove directories and remove files and so on. Furthermore, one thing we've done is we've designed it explicitly to support JVM scripting languages. So for example, here you see a Groovy file where we're testing for the existence of a directory. If it's not there, we create it, copy some data, and then change its permissions. And so what you can do is you can have these HDFS Groovy scripts, for example, lying around. And inside your application context, you can then reference them and also pass in additional variables. So all of these taken together allow you to create really a very small, very well structured small workflow through the use of the job runner. The job runner can reference multiple scripts. So there is a pre-action command, attribute on the job runner element, and there you can reference the setup script that I showed in the previous slide. You can reference a particular job, and then you can reference a post-action after the job has successfully completed. So this allows you to sort of build up incrementally, starting from a simple Hello World application to something that resembles a more complex application that would be more typical of what you'd eventually have to write in a very comprehensive big data application. So the runner class also allows you to do scheduling very easily because they implement the JDK callable interface. So that means, for example, you can use Spring's task scheduling features to reference one of these runners and then specify a cron expression so that that particular job could be run over and over again at a particular time. And this really is just sort of a stepping stone, meaning that it's a very simple linear flow. If you want to do more complex graphs in terms of the workflow, then you sort of graduate to using the extensions we provided in the Spring Batch project. I'm not going to get very deep into Pig, but Pig is another way you can analyze data that's stored in HDFS. It's sort of a data flow-like language. And what I just want to show here is that you can bootstrap it using this element called Pig Factory. You can, again, define a script. And here's a PigRunner class where you're executing that script at startup. And all of this, in terms of the variables here, are being replaced using the standard Spring property placeholders mechanisms. Similarly, just for a Pig template, you can define basically the bootstrap, the connectivity of Pig, then reference a Pig template, and there are similar classes for Hive and HBase. And really what this looks like is essentially in this method here, you can inject both, let's say, the Pig template and the output directory, and very simply specify a few properties, and then have it execute the script. And in Hive or Pig, if you use the normal APIs, this is much more verbose and problematic than you see here. Okay, where I'd like to go next is really to discuss stepping up the complexity a bit in what you can do with Spring for Apache Hadoop. And the fundamental observation here is that big data problems are really also integration problems. There's a series of steps that you have to do in a complete solution. the data that you want to have in HDFS needs to be collected. Often this could be syslog events, it could be Twitter files, it could be something that you really never thought to collect before because it was cost prohibitive, but now you can collect it and analyze it and presumably get a good return on your investment in terms of the decisions you'll make at the end of your analysis phase to drive different changes in your website or choose different properties of your application to usually generate more revenue. So the collection aspect is highly distributed and high throughput requirements. There's usually a transformation step of that raw data before it's stored in HDFS. And similarly, as the data is streaming in, is a good opportunity to actually do some monitoring on that data for its quality, as well as some real-time analysis, which could be as simple as incrementing counters, or it could be much more complex, such as populating a distributed data grid and executing queries against that distributed data grid to see if anything complex has violated certain criteria. Once the data is inside of Hadoop, the steps you need to perform to analyze it is usually more than just one MapReduce job or one pig script. It's usually a series of them, and you need to orchestrate that batch analysis. The end of the analysis step, you have to export the data that's been stored in HDFS to some other system so it's more easily manageable in terms of business intelligence or creating reports for end users to see. So as an example of this, you can imagine that we're using Spring Integration, which has a channel adapter to immediately talk to Twitter. So it's consuming tweets, let's say from a Twitter search. And what it's doing is, in a sample app that we have, it's counting the frequency of hashtags that occur in the tweet and storing that information in Redis. Similarly, it can store tweets inside of Gemfire, distributed data grid. And Gemfire has a feature called continuous query, which allows you to basically monitor the data set with a SQL-like query, and when there's something that satisfies that condition, an event will be fired. But the main pathway that we're usually concerned about is, of course, storing all the data, and here there are adapters from Spring Integration into Hadoop as well as Splunk. And once it's sitting, for example, inside Splunk, that's when you can use Spring for Apache Hadoop in combination with Spring Batch to orchestrate the workflow, the contents of which can then later be presented over the web, perhaps using Spring MVC. So first, just a few words for those who aren't familiar with Spring Integration, what it is. It's an implementation of the patterns described in the book Enterprise Integration Pattems by Gregor Hope and Bobby Wolf. It's been around for a while. It's pretty mature, from 2007, also Apache licensed. And one thing it's particularly good at is separating the code that's related to integration concerns with the code that you have to write, your business logic or processing logic. So it's responsible, meaning the framework, for handling the message reception and invoking methods, and you're responsible for plugging in processing logic where you can deal with events as simple POJOs. And the end result of this is that when you need to test your application, it's much easier to test your business logic in isolation. The fundamental structure that Spring Integration follows is a pipes and filters style architecture, where you have messaging flowing over channels between two endpoints. And I'll elaborate that a bit more in the next slide. So in the pipes and filter architecture, you have an endpoint. They are connected through channels, and they exchange messages. And messages have a structure where there's a header and a payload. Endpoint's a very generic term, but you can think of it as something that produces data and something that consumes data. What can be producing data is the contents inside of a file. Maybe an action I take on the data is to route it to one or two different systems, transform part of the data before processing it further and down the chain. Or I can consume, for example, from JMS or really any of the other popular middleware choices. There are many adapters in Spring Integration for various types of middleware. And then I could, for example, send the data that I've modified out over TCP. So Spring Batch, again, just a slide here to set the tone. It's a framework for batch processing. It's the basis of JSR 352, which is part of the EE7 umbrella. And it was born out of collaboration of SpringSource with Essentia in 2007. And the motivation behind this collaboration was that Essentia was doing a lot of business around traditional batch processing. And in order to increase their efficiency, they wanted to develop a framework so they can create repeatable solutions and capture common design patterns. And so some of the features of Spring Batch directly relate to the batch domain. These are things such as lots of parsers and readers and writers for flat files and CSV structures, the idea that there should be retries after failure because there could be partial failures. There's the ability to do processing in parallel and to restart your jobs after they failed from the point at which they failed. In the upper right of this slide, you can see really the basic structure of a job. A job consists of a graph of steps, and the job proceeds basically through these steps, and it can be branches and joins to these steps as well. So it's, generally speaking, a directed graph. The step itself has a structure where you have something that reads the data, an optional processing step, and then something that writes the data. And so in terms of the use cases around ingestion and export, if you're dealing with event streams, Spring Integration is particularly well suited. Examples of this would be consuming syslog events, transforming them, and then writing them to HDFS, or in this slide I showed earlier, consuming Twitter search results and writing those into HDFS. Another example of ingestion is using, or export, is using Spring Batch. So if you want to read files on a local file system, transform and write them into HDFS, that's a very common occurrence using Spring Batch. And since HDFS is really just another file system, it's quite straightforward to also read from it, transform the messages, and write to another target system such as JDBC, HBase, or Mongo. Reading from files and writing to JDBC is really the bread and butter of Spring Batch since the beginning, so it's a quite mature feature set for that domain. In terms of analytics, the family of Spring Data projects, as well as integration and batch, come into play. If you're doing real-time analytics inside the part of a Spring integration pipeline that does processing, the service activator, you can leverage several of the Spring Data projects and their helper classes. So, for example, in the case of Redis, there's Redis template. In the case of Mongo, there's Mongo template. And you can literally have one-liners, for example, to increment, let's say in Redis, a z-set such that you can keep track of the frequency of hash tags that are in a tweet. There's also support for Gemfire inside of the Spring Data project. In fact, the Spring Data Gemfire library is part of the Gemfire distribution now as of its 7.0 release. So there's nice integration that you can take advantage of there if you happen to be a Gemfire user. And last but not least is around the actual analytics of running Hadoop jobs. We've integrated with Spring Batch such that you can orchestrate the various steps in a Hadoop-focused workflow. But because Spring Batch existed before the predominance of batch processing in Hadoop, it's also very easy to mix in non-Hadoop-based workflows such as those from relational databases. So here are just some pictures to kind of show some of the use cases in action. I took these snapshots from the SpringSource Tool Suite editing support for Spring integration. If you're using syslog into HDFS, really you have a few things to configure or assemble. You would pick to use Spring Integration syslog adapter. In this case, I did a little transformation on the data. And here I chose to route to two endpoints, the data based on category. All of the data goes into HDFS, but only a filtered subset of the data I was writing into Redis. This is all occurring on a single machine. The ability to have channels as the components that separate the processing steps makes it very easy for you to sort of snip the graph and move part of the collection process off into another machine. So here what I show is taking that previous flow and snipping it basically after the collection from the syslog event. Now there are two machines collecting data on syslog, and they're using the TCP adapters to forward them to another machine that does additional processing. And one thing that's very nice in terms of this structure and this modularity is that if you chose to use a different type of messaging middleware to push the data from one machine to another, this would just be a simple configuration change of a very small isolated part of the overall pipeline. Here's where I show a little bit more about how Spring Batch was extended through its extension points to support running Hadoop jobs. So on the bottom right here, you have a simple graph of steps. The first step can be doing HDFS operations. The second step can be executing a pig script. Then I can split and execute two steps in parallel, one being a MapReduce job, another executing a Hive script. And then when they both complete, there's a final step that does some HDFS operations. This slide basically shows a visualization inside the Spring Source tool suite for this, as well as the XML that lists how you order the steps and how you can split the flow into two parallel steps. So for the case of exporting data from HDFS to JDBC, you can really start actually quite easily. These are all classes that exist in Spring Batch now. Just one small change to support HDFS. It comes from the Spring for Apache Hadoop project. And really in this step, you're saying I'd like to read a chunk of data from a flat file, process it a little bit, and then write it into JDBC. And here you can see some of Spring Batch's features as it relates to doing optimizations for inserting data at a high rate. It's picking a commit interval that's optimal for the inserts, in this case 100, and a very simple policy around retries, namely I'll try to do the insert into the database up to 3 times before abandoning that step. There are other more sophisticated retries policies that you can have. This is just showing a very simple one. And so the relationship between all these projects is summarized here in this graph. If you're just starting out, you can really just use nothing more than the Spring Framework and Spring for Apache Hadoop. This will let you connect to Hadoop quite easily, you, configure that inside the Spring application context, submit jobs, interact with HDFS, similarly use Pig template, Hive template, HBase template for a consistent set of APIs to access those technologies. And then as your needs grow, you can start to bring in more of the different projects to get more sophisticated. So in the case of just the base Spring for Apache Hadoop project, there's a simple runner class that encapsulates a simple workflow. But if you want to do something much more sophisticated, you can still reuse those existing job definitions and script definitions, but plug them into a much more robust Spring Batch workflow engine. Similarly, if you're going to be consuming a lot of events and want to make use of all the different adapters that Spring Integration provides versus a smaller subset that's part of the Spring Framework, then for those type of applications, you can bring in Spring Integration. So the idea here is to start small, get your hands dirty, just doing the basic stuff, and slowly graduate up the ladder until you create a very powerful solution. So hopefully the path from beginning to a complete complex solution is relatively straightforward. So some of the next steps we're doing are to really simplify this in a great way and not have it be just a collection of projects that you have to assemble yourself. The new open source umbrella project that we're starting and announcing today is called Spring XD, where the XD stands for extreme data, or for those not happy with that, it could be the X as in linear algebra, y equals mx plus b, so it's anything you want. And this umbrella project is to support the common big data use cases, which we've covered. This is high throughput ingestion into HDFS from a variety of sources, real-time analytics at ingestion time, on and off Hadoop workflow orchestration, and high throughput data export. And what we're doing here is providing really a new consistent model that spans across these 4 use case categories. And most importantly, I think, moving beyond delivering a set of libraries. We're going to provide an out-of-the-box executable server that covers these 4 use cases, as well as a high-level DSL that allows you to configure this so you don't have to muck with XML configuration if you're sitting at the lower levels. So this DSL that, as we've prototyped it over the past year or so, is as simple as HTTP pipe HDFS. And in this case, what that represents is I'd like to consume data from an HTTP endpoint using, let's say, all of the defaults, port 80, and I'd like to write into HDFS, again, assuming a whole range of defaults for where the location of the name node is in the directory. Any options that you'd like to specify to these components will be done with like a dash. So you say HDFS -- output dir equals, temp foo. When you do want to customize endpoints or introduce a new one, it will be through a new module system we'll provide. So the plugin will still require you to have Spring knowledge, but end users who need to consume that plugin don't need to have any knowledge other than the high-level DSL to use it. So there's a blog post that will be put up on springsource.org today, but I invite you to go to GitHub, where we've opened up the Spring XD repository. Right now, we're literally in our first sprint, so it's very early. So it's a great time to get involved and give us feedback, and we'll be putting in stuff over the next this week and following weeks, hopefully making a small little video at the end of each sprint to show you guys what we've been up to. And I encourage you to check it out and give us some feedback. So some resources that are available to you. You can check out all the information that Adam was talking about Pivotal HD and HAWQ. Go to gopivotal.com. There is the Spring Data homepage, and specifically the Spring Hadoop page, where you can find out more information on Spring Hadoop. And if you really want to get deeper, I suggest looking into the Spring Data book, which was written by the Spring Data team. There's a part 3 on big data that covers a lot of the use cases I've discussed here. And the example code that goes along with that book is on GitHub as well, and that should really be able to get you up and running fairly quickly, but we like to go much further in terms of that out-of-box experience, and that's what the Spring XD project is all about. Okay, I see that there were quite a lot of questions along the way. Maybe we can now start to go through that list of questions.
Sounds good, Mark. So one of the first ones I had teed up for you, a lot of the sort of Adam specific questions he's been very diligent in answering while you've been chatting, while you've been talking.
Go Adam.
One of the
I'm sad.
He's been rocking it. One of the first ones though that I actually wanted to revisit was a question that I think has an answer from both of your perspectives by Ravi V. He said, how is the end user going to review the results from HDFS? And Adam responded that HDFS has a Java API as well as a command line utility to interact with the file system. But I wanted, Mark, maybe for you to take a crack at that, because I thought with Spring for Apache Hadoop, there might be some MVC ability.
Yeah,
there.
so I mean, the end result of running MapReduce jobs are files in a specific format in HDFS. So I mean, if it's a text format, literally you could cat them. You'd probably see some CSV-like data in there in the most simple case. Maybe not the most optimal, but that would be the most simple. And so the last step, really, of what I was calling export is how do you get that data out into something that's more queryable, that's more selectable, that allows you to create visualizations. And so that last part, could even be exporting into our data sets, which is a statistical package that a lot of people use. So that last step there's an export step, basically. There's still a lot of data, but not nearly as much data as was processed on the input side of the MapReduce job. And so that export step is really the last mile to getting the analysis results to the user. So once it's in Mongo or JDBC, maybe you connect a standard business intelligence tool to it. Maybe you write a custom web app using Spring MVC. I think everyone has their own sort of preference there in terms of what they use as the visualization technology.
Excellent, thanks. I just wanted to make sure that we covered it from that perspective as well. I think in the last webinar we talked about whether there were any ISO or VM images, and the answer was not yet, but put something into Jira if you want one.
Yeah, it's interesting. Yeah, I mean, we plan to, interesting it came up again. Yeah, we plan to literally ship a tar.gz file, and then you unzip it. But, it sounds like there's demand for having a VM image or an AMI image. And as we'll be using, Amazon ourselves extensively, we can make those available. Yeah, it sounds like people want that. So if you want it, we definitely very interested to hear that feedback to make it as easy to consume as possible for you guys and gals.
Great. Yep. Okay. Next question from Sandeep. Mukherjee, does Spring Tool Suite support Spring for Apache Hadoop?
It does in the sense that what we've provided are extensions to Spring Batch and parts, different channel adapters for Spring integration. So in as much as there's support for those technologies in STS, there's a way for you to sort of leverage that inside of Spring for Apache Hadoop. But there's no other new visualization support. What we're doing in XD is opening up a whole set of RESTful APIs to get at monitoring information and creating new flows of data and registering jobs. Those familiar with Spring Batch Admin project, it's something similar to that. So we're not going to be designing a whole new UI, but we will be making it easy, much like Amazon does, to hook up into it from UIs, because the external facing part of the server in Spring XD will be the RESTful endpoint.
Awesome, thanks. Question I'm curious to hear about as well. Sathian asks, is there any performance degradation if they use Spring for Apache Hadoop versus just using Java to implement the MapReduce?
Right. So if you're using, you still write if you're writing MapReduce code, you still write the MapReduce code as you would have done always. Very early on, we had actually dependency injection for the MapReduce job, but we chose not to go that way for a variety of reasons I won't get into. But the answer is basically no. You write the same, literally code you wrote always, and what we're doing here is instead of, writing Java code to configure a job using the Hadoop APIs, we're providing integration through an XML namespace for you to declare and configure those jobs inside of a Spring application context. So the runtime aspect is completely the same. The only difference is the configuration part at startup, which in the case of these jobs is completely negligible. I mean, these jobs can take, minutes to hours versus the startup time of parsing some XML.
Awesome. Now, this may be an Adam question. I'm not sure, but this comes from Kishore Kumar. Is it possible to configure Spring in NFS directly with Hadoop? I understand it's a duplicate question, and he says he apologizes.
Yeah. Well, Adam probably knows all the different file systems that, Isilon is one case, but I believe there is some NFS support as well, if I remember.
Yeah. So Isilon, I guess, is a more enterprise way of kind of exposing an NFS to HDFS. There's other projects. I think Fuse is one of them, and another called Mountable HDFS that essentially lets you put HDFS, expose it through an NFS interface. I haven't worked with them enough, I guess, to kind of test how good they are, though. For the most part, I've had some questions in the past about, people using NFS as like a storage layer for Hadoop, but that's not the way to go. You just want to use the local file systems for it rather than kind of NFS, because that'd just be too slow.
Right, yeah, that would just add kind of a slower performance link where you just kind of throw in a network hop there when you wouldn't need to.
Yeah, exactly.
Yeah. Okay. Next question is from Sambi Reddy. How is Hadoop or Spring Hadoop used for submitting jobs remotely?
Right. So right now, in the Spring Batch admin project, there's a means for you to upload a workflow file and then schedule for execution. That I think is a little too hidden right now for people. There was a sample app we wrote with a command line interface to facilitate that. I didn't put the link up. But that exact thing, which this is actually the quintessential problem we have right now and what we're trying to address in Spring XD. This is totally possible to do, except you need to stitch together 4 things that, unless you're diligent or really read the docs, you might not find. And so that exact case of, let's say, authoring a small workflow and specifying a few Hive or Pig scripts and uploading that somewhere and running it is what we want to make a lot easier in Spring XD. So it's possible today, but you need a little bit of elbow grease, and we want to make that elbow grease, not necessary in the Spring XD project.
Sounds like a lot of elbow grease. Okay, so next one is from Tushar Patel. And his question is, what about exception handling? And Mark, I think you were on a slide that was talking about Pig when he asked that. I wish I could
so it's probably with those little small workflow questions. So, for example, if the job doesn't, if there's an exception thrown in this little processing chain, really we log it and we continue to the next step. So it's very simple in that regard. In terms of exception handling inside of Spring Batch, it's much, much more robust. You have policies. Should you abandon a job on this exception? Should you abandon the job on this exception if it occurs a number of times? If there is an exception, where should you branch to? So really the runner classes, where the slide you saw this with PigRunner, is really meant to be pretty lightweight. It's not going to be the world's most robust solution as compared to the features that Spring Batch has. But that said, it's a lot better than really stringing stuff together in a Perl script or stringing it together in your own code. If there's something we've done wrong there, like we want a different policy, we can go back and certainly revisit the decisions that we made in terms of how the flow occurs in those runner classes if there's an error. So I'd love to hear feedback through Jira if you think there's some improvement we can make there.
Thanks, Mark. Sambi Reddy, again, another question from him asks, and I'm sorry, I don't know what slide you were on when he asked this one, but he said, is Spring Runner jar responsible for loading the context and submitting the jobs? Can you confirm that's the case?
So that was literally a one-line main class that said new class path application context, and then took the first argument, which was the XML file, and ran it and said, refresh. So it's literally a one-liner file. And if you look at the Spring Hadoop book examples, you'll see it there. It's literally just the line of code that, news up an application context. So it's like 2 lines.
Got it. Okay. We still got a couple more questions. Mark, if you're okay and going over, there's
we can go on
few more.
All day long.
All right. Adam, there may be 1 or 2 for you lurking in here. I'm not sure, but I think you've been pretty diligent at looping through here. Srini Ivaturi asks, are there any plans to support Storm and Kafka in Spring?
Oh, yeah. So Kafka, there is a Spring Integration Extension project, so it adds channel adapters for integrating with Kafka as the middleware. And Storm, actually, I think we'll probably end up competing a bit with Storm more than integrating with it. But that said, this is all open source, and lots of people have different itches to scratch. So we're not completely focused on that. But I have seen people using Storm and Spring together. I've seen a few mails on the mailing list about that. It's something we should pay attention to, but we don't have any direct plans to provide that integration.
Gotcha. Next, this is a juicy one. William Chung asked, does Spring Batch have a notion of checkpointing? Checkpointing like a point in the job chain where if your infrastructure goes down, when you come back up, you can continue from the last checkpoint to the beginning of the job chain.
Yeah, it definitely does. That's one of the key features. If I go back, I don't know if I can go back quick enough. Let's see, maybe I can do it this way. Yeah, this is pretty good. So on the slide I just put up now, you see this job repository. Basically, when a job is launched, it goes to step 1, and then it says, okay, I'm done with step 1, and it updates the job repository saying, job instance number 1 has reached step, the start of step 2, right? Then it tries to do step 2, and if it works and succeeds, it says, okay, I'm on to step 3, and at every step along the way, it's persisting this information in a database. So this feature around job tracking and restart, there's a lot of depth in terms of, when do you consider a step failed? Is a step restartable to begin with? Maybe it's not. So yes, definitely there is a concept like that, and the idea is that you could have a job that's 50 steps long, and imagine it took 3 hours to do that, and it failed on the last step. You definitely do not have to start from step 1. You can start from step 49.
Excellent. Yeah, I had a feeling you would say that would be a Spring Batch use case. So this is another potentially juicy one, and I'm not sure who this one's really for, to be honest, but VR asks, in many big data scenarios, the data is constantly being written to the store, and that brings up the question of data consistency in their query results. Is there a transaction-like concept, or are the results indeterminate?
Sorry, can you repeat that again? I was
no
trying
problem.
to type an answer to a question at the same time. Or maybe Adam wants to answer it, I don't know.
Sure, no worries. I'll say it again. In many big data scenarios, the data is constantly being written to the store, which brings up the question of data consistency in the query results. Is there a transaction-like concept, or are the results indeterminate?
So I guess I can take a stab at that one. So
sure.
If you're using HAWQ to kind of natively store the data, it does support transactions at that state. So whatever you put in there, it'll be there and available for query. However, if you're using like external tables, either through files in HDFS or say like HBase, the behavior, I guess, is a little bit different, mainly because it's like until a file is actually closed in HDFS, you can't really read it per se. So you can read, like the block will be closed, so you can read the data from the block, but anything that's being written to a current block is not going to be available for a query at that time. But if you natively store it in HAWQ, then yeah, it is ACID compliant and everything.
Got it. Okay. Let's see. Mark, looks like you're getting ahead of me in the question queue. Okay. Here we go. Eric Bressy asks, if you have a data collection node, which you capture data but it's disconnected, can you potentially do some tasks locally, but need to do further tasks on a data warehouse type node? Does this support syncing the results and further processing on the server?
I'm not sure I get the question.
Yeah, let me read it again and see if I can kind of dynamically reword here.
Where is the question?
I'd say it's about 3/4 down, 10:51 a.m. Eric Brezzi. Looks like he wants to kind of capture data.
Oh, I see. Okay.
Do data capture and some sort of
disconnected. So let me just take the thing in case you're capturing disconnected. So in Spring Integration, you're writing to an outbound channel adapter that talks to the next node. It could be TCP. And the channel itself can be backed with a persistent store that could be file, database, or a few other choices. So in terms of a temporary disconnection, you could still, if you choose to, right, take the hit to write that data locally, persist the data locally, and then when the connection is restored, it'll drain that persistent channel and then send it on its way. And then you can potentially do some tests locally in different syncing the results. Yeah, so I mean, what you can do in this is that, Spring Integration and Enterprise Integration Patterns, definitely has this concept of waiting for responses in terms of an aggregator component. So, for example, you can say, I'm going to wait in this aggregator component until I get the responses from these 3 systems. And when I get those responses, that means that everything's synced, and now I can continue processing. So, if that's what you mean, you can do that kind of scenario. I hope that helped.
Eric, if you're still on, please feel free to clarify in a subsequent question. It does look like you're still on the webinar as far as I can tell. Another question from Adrian. If I want to replace an existing relational database to support large data and relationships and large number of clients, is Hadoop the way to go, or should I use HBase or Hive or HAWQ? I know this is kind of a generic question, but I thought it might open up some interesting possibilities.
So that it largely depends on the use cases. Like some stuff might obviously fit well just in like native Hadoop, Java MapReduce, or Hive type things. There are many different ways, like through Scoop or Data Loader, to actually get your data off of your more legacy databases and into HDFS. At that point, I'd say just really kind of start playing around with tools like Pig and Hive and even HAWQ, I guess, to kind of see, I guess, what it is, what's the best solution for whatever your use case is. Now, HAWQ is going to give you more of that MPP feel, so that will feel more native. But if you had like huge data problems, HAWQ's not going to be the best at everything. Maybe you need Java MapReduce to do like huge ETL processes that go through massive amounts of data and produce massive amounts of data as output. HAWQ's not really more designed for that.
Perfect.
To answer some of that.
Yeah, it's kind of a general question. So, let's see. Praveen has 2 questions. Well, actually, no, it's one. Sorry. Do you have any predefined parser for standard file formats like HIPAA files to be used with Hadoop, for data analytics?
I don't know about HIPAA files. I imagine there'd be something out there. Hadoop's grown, so there's a lot of different input formats and supported file types. From the HAWQ side of things, it's kind of the native format that it has, and through the Xtension Framework, it can read like CSV or tab delimited files stored in HDFS, stuff in HBase, stuff in like Hive, and kind of as that Xtension Framework grows, it'll be able to support more and more data types. It also supports like Avro formats and sequence files in Hadoop.
Got it. Okay. Let's see. I think we're getting towards the end here. I think we answered the Storm and Kafka question. Yeah, okay. No, we don't have any samples. Sorry, Praveen. No, we don't have any samples on how to parse the HIPAA and formatted data using MapReduce jobs.
Yeah, there might be.
I don't know, maybe we have some ANSI SQL.
Well, if you're
CSV.
Let me just look up one thing. Trying to find this email from John Davies.
Well, we may not have a sample for HIPAA, but maybe for like a generic flat file, perhaps.
Well, generic flat files, yeah, those are things. But there's a company that we partnered with in the past called C24 that may have these type of adapters. They have a lot for finance. I don't know if they have for HIPAA, but anyway.
I'll see if I can get Praveen, if you want to put your email into the question queue. Maybe we can follow up with you offline. Mm-hmm. Looks like you're still in the webinar, or I believe you are. Okay. Slim Baltegi asks, what are the main features of Pivotal HD versus the other Hadoop distributions besides HAWQ? Okay,
so outside of, I suppose, just the Apache ones, the major things are the command center for actually doing a managed installation of, HDFS, as well as like HBase installations. And through the command center, has a web UI for taking a look, at the overall health and status of your cluster, which some other distributions have that as well. Another one is the Hadoop virtualization extension, which I don't think any other distribution has, to essentially let your HDFS clusters know, as well as the MapReduce side of the house, kind of that your environment is actually virtualized, so it has smarter replica placement policies as well as kind of task placement policies. The other big one is data loader, which is probably most similar to things like a Scoop and Flume and Apache World to actually pull data into your HDFS cluster in parallel.
And that actually, I think, may answer another related question from Adalto Martins, and who was asking, can we virtualize the HDFS nodes, and is this a good idea?
Yeah, so virtualization is huge, and we've seen a lot of our clients and partners do that. And one thing I didn't touch on in this presentation, one of the big pivotal bets is that virtualization is going to be huge in the future, so we're going to start working in Cloud Foundry, or like you can deploy to Cloud Foundry, deploy to AWS, and through these virtualization extensions, making more Hadoop virtualization friendly is going to be really big.
Okay, I think we're almost out of questions. There's only just one or two more, guys. Thanks for running so long, and yes, the QA. This is all still being recorded, so this will be posted. Let's see. Disclaimer from VR says this may not make sense to answer, but are there any tools for data cleansing, reaping, tombstoning? Parenthesis, reclaiming data storage that was used but no longer needed. And his scenario is that the data model has changed and that there's a need to backfill.
I don't know of any sort of intelligent tools that can do that. I've seen things before where they've implemented like automatic deletions from the framework, knowing like this data, I have a 7-day retention policy or something. So
yeah, I think there's also a mechanism to slowly reduce the number of replicas.
Mm-hmm. Okay.
And mark those as free. But yeah, I don't know how automated any of this is, but there are definitely sort of tricks of the trade there.
Yeah.
Very good.
Good old deletion.
Kill -9. The HBase Java API does not support joins or ACID transactions, last I checked. Does the new SQL API HAWQ support these features? Thanks, and sorry if this has been previously addressed.
Yeah, you're right. HBase doesn't support joins or any of these ACID-type transactions. SQL, or HAWQ, I should say, it does support joins. It's ANSI SQL compliance 92, 99, 2003, I believe, as well as ACID transactions in their native format, and rollbacks as well and everything.
One last question, then there's a comment that I can't resist sharing with you. Are there any plans to provide information for billing back to departments or services? This is the kind of chargeback use case that issue queries in terms of the resource usage. Hey, kick in, pay for what you use, kind of thing.
Nothing native that I suppose I know of, but I definitely see things like that before. People will build like small little applications that'll scrape like all the logs, or like the name node logs every single transaction that it has. I think it's called like the audit logger. Basically kind of scrape these log files and see what's going on and who's using what. But I don't know of any projects.
I mean, one thing you do get through the running it on virtualization is that you can, I don't know if this is supported now, but I believe the goal is with virtualization support is to use the standard virtualization controls, so you can create different virtual clusters on the same physical hardware, and then if 3 departments chipped in to purchase that hardware, you can then use standard sort of VMware virtualization controls to say that department gets a third, that department gets 50%, and the other one gets the remainder. So there are those kind of techniques at the virtualization layer to at least segment up the resources. Might not be billing back, but there is something along those lines that people are attracted to when running Hadoop in a virtual environment.
And kind of going on Adam's angle there, I think Mark and we did a webinar recently talking about how we've integrated Splunk with Spring integration, and they're quite good at doing log file analysis, although that would just be infrastructure. It wouldn't be any sort of out-of-the-box chargeback solution.
Yeah, you have to use Hadoop itself to eat its own dog food.
Yeah, very likely.
Eat its own exhaust.
And in summary, a comment from Girish says, thanks to you all, a lot of info, it may blow up his head. So I appreciate you guys going so long. We still have 218 people left, which is amazing. And I think just let's wrap up. And just want to remind you guys, Mark, if you want to pull up that URL slide while I'm just doing my little conclusion here.
No
the GitHub and Jira repository for the Spring XD project should be live in the next 24 to 48 hours. We certainly encourage you to check out Spring for Apache Hadoop, and we may be instituting some programs to give away copies of the Spring Databook again very soon. So feel free to ping us on @SpringSource on Twitter about that if you're interested in a free copy. And we're having a major launch tomorrow of the actual new Pivotal organization tomorrow at 10 a.m. If you're curious about sort of what's going on sort of macro level, big picture around all this technology and what the launch of the company is about and where we're going, you may want to join us tomorrow at 10 a.m. The information is on gopivotal.com, and you can register there. And then, obviously, we'll be posting a webinar replay within about 1 to 2 weeks, and we always post those on our YouTube channel, which is SpringSource Dev, and we do our best to post that in HD. So great. Thanks, everyone. Mark, Adam, really appreciate all your patience with the questions and the detail, and we look forward to seeing you on another webinar.
Thank you.
All right. Thanks, everyone, for attending. Appreciate it.